Leicester University is a hotbed of new research aimed at defeating prostate cancer. 30,000 new cases of the disease are diagnosed in the United Kingdom each year and is responsible for nearly 10,000 deaths annually. The research team from the university's physics, chemistry and biomedical sciences departments believe it's now on the brink of developing an effective strategy for the early diagnosis and treatment of prostate tumours.
The big technological breakthrough is that we've been able to deposit these gas phase nanoparticles with all the flexibility in their manufacture into water. Now, this is a very difficult thing to do technically because the particles have to be made in ultra-high vacuum conditions so that all the materials remain clean. And normally putting water into an ultra-high vacuum system is a no-no. What we've done is we found a way of injecting the water as a molecular beam so that it impinges on a very cold plate at liquid nitrogen temperature, and at that temperature it produces no outgassing, produces no contamination through the rest of the system.
The iron core nanoparticles are given a gold shell during manufacture to stop oxidation and to protect magnetic properties critical to their role in identifying and treating prostate cancer cells. While physicists pioneered making stable non-toxic nanoparticles, chemists have found a way to make them soluble and design target molecules to attach to the particles.
So these particles at the moment are typically not very soluble in water, so therefore you need to render them water soluble or biocompatible, so compatible for biological systems. And so what we do in the chemistry department here is to coat these particles with molecules that render these particles water soluble. So then we have to link a targeting molecule that will bind specifically to the cell surface of a prostate cancer cell, and will only bind to a prostate cancer cell preferentially over a normal prostate cell. So this is the way that we can get now selective delivery to prostate cancer tumours over other cells in the body.
When nanoparticles are injected into a patient, urologists are able to locate tumour cells using magnetic resonance imaging and kill the cells by heating the particles with microwaves. Preliminary results of the diagnosis and treatment strategy are extremely positive.
It's completely generic because if the method works, it'll work for any cancer. All you need to do is to find the right targeting molecule so that the particles find the specific cancer that you're looking for. I mean, one of the things that we hope to move on to is liver cancer, because that is something that's very difficult to treat by any other method, partly because the cancer breaks up into very, very complex morphology and very small bits scattered through the liver. Now, the advantage of our technology is that it doesn't matter how small the bit of cancer is, the nanoparticles should find it. And once they're in place, you can apply the heat and kill the cancer.
The research is funded by a £321,000 grant, and the team is now hoping to attract further funding as medical experts see the potential of nanotechnology in treating other cancers and diseases.